Hello and welcome back, everyone, to yet another fascinating conversation where we explore the transformative world of AI. Today, we are diving deeper into insights from the Fourth Industrial Revolution and 100 Years of AI by Dr. Alok Aggarwal.
Last time, we had a captivating discussion about the metaverse, looking into how it is being utilized today, the challenges it faces, and what the future might hold.
In today's discussion, we are shifting gears to explore 6 distinct categories of robots that are already making a significant impact. See how they're being used in everything from healthcare to space exploration, and discover how AI is pushing their capabilities even further. Let's get started.
People often think of robots as a thing of the future, but as we'll see, they're already deeply integrated into our present.
That's so true. The book outlines the different categories of robots, each with unique capabilities and applications.
It's amazing how diverse the world of robots already is. It makes you wonder, where were these robots, say 50 years ago?
Well, robotics has come a long way. And to illustrate this, the book introduces us to Electro.
Yep, the world's first humanoid robot, built back in 1937.
What was that like?
Picture a 7-foot-tall, 265-pound metal man.
Whoa, that's huge.
It could walk, talk, and even smoke cigarettes.
Wait, a smoking robot? That's both hilarious and kind of concerning.
It was definitely a product of its time, for sure. But, Electro's quirky features really highlight just how far robotics has come since then.
I see what you mean. From a novelty smoking robot to robots performing surgery and exploring Mars, the progress is astounding.
It really is. And the pace of innovation is only accelerating.
Which brings up another point from the book, the sheer scale of this robotic revolution. The chapter mentions some pretty big market projections, right?
It does. By some estimates, the global market for robotics is expected to reach hundreds of billions of dollars in the next few years.
Wow, that's massive.
With annual growth rates exceeding 10%.
So this isn't some niche technology anymore. Robots are going mainstream.
Precisely.
Okay, let's jump into the first category of robots, industrial, collaborative, and medical robots. What makes them tick?
These robots might not be as visually captivating as some of the others, but they are workhorses. They're typically immobile, meaning they don't move around freely, but they're designed for very specific, high-precision tasks.
So like those massive robotic arms you see on car assembly lines welding and moving heavy parts.
Exactly. A great example is ABB's industrial robots. They've sold over 400,000 of these robots worldwide, used in a huge variety of industries.
So they're the heavy lifters of the robot world, literally. But what about those collaborative robots, or cobots as the author calls them? How are they different?
Cobots are designed to work alongside humans. They're equipped with advanced sensors and safety protocols so they can interact safely with their human coworkers.
So instead of replacing human jobs, they're actually enhancing human capabilities.
Exactly.
It's fascinating how robots are becoming more integrated into our workplaces, not as replacements, but as partners.
It is.
Okay, and then we have medical robots. What kind of tasks are they tackling?
Think precision and minimally invasive procedures. A prime example is the Da Vinci surgical system, which is used in thousands of surgeries every year. From prostatectomies to heart valve repairs, these robots allow surgeons to perform incredibly delicate movements with minimal invasiveness, leading to faster recovery times and fewer complications.
It's amazing how robots are already transforming healthcare.
They are.
And it sounds like these immobile robots are at the forefront of that revolution.
And it's only the beginning. But let's shift gears now and talk about the robots that tend to capture our imaginations the most. Mobile robots.
Okay, I'm all ears. This is where things get really interesting. Give me some examples of what these mobile robots are up to.
Think of Boston Dynamics Spot, a 4-legged robot inspired by canines.
Oh yeah, I've seen videos of Spot. It's incredibly agile. It can run, jump, climb stairs.
And even detect bombs.
Really? So they're being used in dangerous environments where human access is limited.
Absolutely. But mobile robots aren't just limited to Earth. Remember those incredible images from the Mars exploration rovers?
Of course. Spirit and Opportunity, they sent back some breathtaking pictures of the Martian surface.
And then there are robots like Google Spot Mini, which can tackle more mundane tasks like stacking dishes and loading the dishwasher.
Okay, that one hits a little closer to home.
It does, doesn't it?
It seems like with mobile robots, The sky's the limit.
It really does. But let's move on to our third category, which takes mobility to another level. Remote-controlled robots. This category includes things like automated guided vehicles, or AGVs for short, autonomous mobile robots, or AMRs,
Wow. Lots of acronyms.
and autonomous mobile manipulation robots, AMMRs.
Can you break down the differences for us?
Think of it like this. AGVs follow pre-programmed routes like the robots that move materials around in factories. AMRs are more sophisticated. They can create maps, avoid obstacles, and even optimize their routes.
So, AMRs are like self-driving cars, but for warehouses and factories.
Exactly. And AMMRs take it a step further.
How so?
They're like AMRs, but with the added ability to manipulate objects.
Like they can pick things up and move them around.
Exactly. Making them incredibly useful for a wide range of tasks.
It sounds like these remote-controlled robots are at the heart of modern logistics and manufacturing.
They are. And we can't forget about drones, which are a rapidly growing segment of the AMR market.
Drones are everywhere these days. They're used for everything from photography to package delivery.
And they're becoming increasingly autonomous.
So they can even operate completely independently, right?
Absolutely. Making them ideal for tasks like inspecting infrastructure or monitoring crops.
It's incredible to think about how far remote-controlled robots have come, and the impact they're already having on our lives.
It is. But let's switch gears again and talk about something even more mind-boggling. The fourth category, nanorobots.
Okay. This sounds like something straight out of science fiction.
They are so tiny, they operate on a microscopic level.
What are these tiny robots doing?
Nanobots are still largely in the research and development phase, but the potential is incredible. Imagine robots that can travel through your bloodstream while delivering medications directly to specific cells, or even repairing damaged tissues.
Oh, that's mind-blowing. But surely there are some big challenges with building and controlling robots that small?
Absolutely. Scientists are still working to overcome those challenges. But while there's still a lot of work to be done, the potential of nanorobotics is truly transformative.
Okay, so we've covered immobile robots, mobile robots, remote-controlled robots, and now microscopic robots. What's next on our list?
Let's step back into a more familiar realm with humanoid robots and chatbots. You're probably already familiar with chatbots like Siri and Alexa.
Definitely, I use them every day. But I wouldn't exactly call them humanoid.
True. Siri and Alexa are more like disembodied voices, but there are robots that are becoming increasingly human-like in their appearance and behavior. For example, think about Honda's Asimo, which can walk, run, climb stairs, and even recognize faces. Or Boston Dynamics' Atlas, which can do backflips.
Wait, a backflipping robot? Okay, now I'm really impressed.
And then there's SoftBank's Pepper, which is designed to interact with humans and supposedly make people happy.
So from backflips to emotional support, these humanoid robots are really pushing the boundaries. But how are they achieving this level of sophistication?
It all comes down to AI, particularly deep learning and large language models. These technologies are enabling robots to process information, learn from their experiences, and interact with humans in more natural and intuitive ways.
It's amazing how AI is blurring the lines between humans and machines. I'm ready for our final category, stationary robots and robotic process automation. What do we need to know about them?
These robots are a bit more behind the scenes, but their impact is significant. They're essentially software-based robots, or digital workers, that automate repetitive tasks like extracting data from documents or filling out forms.
So they're like virtual assistants for businesses.
Exactly. They're revolutionizing office work by freeing up humans from those tedious and time-consuming tasks.
It sounds like these stationary robots are playing a crucial role in increasing efficiency and productivity in the workplace.
They are. But as with any powerful technology, there's a need for careful implementation and oversight.
What do you mean?
Well, these robots rely on well-defined rules to perform their tasks, and they need to be constantly updated. As business processes evolve, it's important to have humans overseeing their work to ensure they're operating smoothly and ethically.
That makes sense. We want to make sure we're using these technologies responsibly. This has been an incredible journey through the world of robots so far. It's amazing to see how diverse and impactful they already are. What are your thoughts so far?
I'm truly fascinated by the sheer breadth of this field. From microscopic nanobots to giant industrial robots. There seems to be a robot for almost every task imaginable.
Exactly. And with AI driving their evolution, the possibilities seem endless.
So where are all these robots actually making a difference right now? Like, what are they actually doing? And what's holding them back from becoming even more common?
Well, I think one of the most impactful areas is the workplace.
Oh, yeah, especially in manufacturing, industries like semiconductors and automobiles. I mean, the numbers are staggering. I think back in 2021, there were 2.7 million robots in operation globally.
Wow. Yeah, that is a lot.
It's huge, and it's only going to grow. But one of the big things that's kind of holding that growth back is making these robots easier to install, like integrating them into existing systems. That seems to be the bottleneck right now.
I hadn't even thought about that. Okay, so moving on. What about robots and healthcare?
Yeah,
We've come a long way since the 1980s. You know those big, clunky machines?
yeah.
I mean, now you have robots assisting in brain surgery, orthopedics, all sorts of really complicated procedures.
Healthcare is actually the second largest sector for robotics after industrial applications.
Really? Wow. But what does that mean for the future of healthcare? Like, are we going to see robots actually performing surgeries? Or is it, more about assisting surgeons? What's your take on that?
Yeah, I think primarily it's about augmenting human skills. Robots can provide surgeons with greater precision. They can give them stability. They can even get to areas that are really hard to reach. So it's really a partnership that can lead to less invasive surgeries, faster recovery times, and, hopefully better outcomes for patients.
Wow, that is really fascinating. So it's like a high-tech helping hand for surgeons.
Precisely.
All right, well, let's shift gears a little bit and talk about robots on the battlefield. I mean, it's no secret that drones are being used more and more in military operations these days, and it goes way beyond that. Surveillance, targeted strikes, it's a lot to think about. What are your thoughts on that?
Well, I think that the same technology that's being used in military applications also has a wide range of civilian applications. Disaster response, you've got delivery services, remote sensing.
That makes sense.
So the potential is really enormous.
It sounds like it. But what's holding us back from using these technologies even more widely?
Well, I think there are a few things. One is the regulations. We've got constantly evolving regulations. The user interfaces for some of these robots can be a bit clunky, and there are still concerns about safety and reliability, especially when you're talking about things like drones.
Right? And the ethical considerations. I mean, when you talk about robots in warfare, there's always that question of, where do we draw the line?
Absolutely.
Well, let's move on from the battlefield to some other hazardous situations, like bomb disposal or underwater engineering, places where it's just too dangerous for humans to go.
Yeah, it's incredible.
What are some of the coolest robot designs being developed for these, extreme environments?
Well, I think some of the coolest ones are the snake-like robots. They're being used for search and rescue. You've got legged robots. They can navigate really difficult terrain. And even teams of robots working together, for things like nuclear cleanup.
I can't even imagine the engineering that goes into that. What are some of the biggest challenges in designing these robots for such, demanding environments?
Well, durability is key. They need to be able to withstand extreme temperatures, radiation, all sorts of unpredictable conditions.
Yeah, that's tough. Okay, so let's go from, the depths of the ocean to the vastness of space. What about robots in space exploration? I mean, we've sent robots to Mars, to other planets. It's amazing what we've been able to do.
Incredible.
What are some of the unique challenges of designing robots for space exploration?
Well, one of the biggest challenges is the communication delay. When you're controlling a robot that's millions of miles away, there's a significant delay in the signals. So you can't do real-time control. So they need a high degree of autonomy.
So they basically have to think for themselves.
They have to some extent. And that requires, sophisticated programming and artificial intelligence.
It's really mind-boggling to think about. Okay, well, let's bring it back down to earth a little bit and talk about robots on the farm. Not something people might immediately think of when they think of robots.
Yeah.
But they're being used more and more in agriculture these days for things like planting, harvesting, even managing livestock. It's all about making food production more efficient and more sustainable.
Right?
What are some of the challenges there? Because, a farm isn't exactly a controlled environment like a factory.
No, it's not.
So, how do you design robots that can handle all the variability of nature?
Yeah, that's one of the biggest challenges. The weather, the soil conditions, even the growth stages of crops, everything is constantly changing on a farm.
So you can't just program a robot to do the same thing over and over again. Okay, well, 2 more areas I want to touch on before we wrap up this part of the discussion. What about robots in construction and mining? These are industries that are known for being dangerous and labor-intensive. Seems like robots could really make a difference there.
Absolutely. I mean, they can handle those tough, repetitive tasks that are dangerous for humans. And they can do it without getting tired. But there are still some hurdles to overcome.
Like what?
Well, one of the big ones is interoperability. And making sure that robots from different companies can work together smoothly. You don't want a bunch of robots on a construction site arguing about whose job it is to, dig the hole.
That would be a mess. All right. What else is holding back this technology?
Well, I think the harsh conditions and limited communication in these environments can be a challenge.
That makes sense.
Construction sites and mines can be dusty, dirty, subject to extreme temperatures, and communication signals can be blocked by obstacles, which makes it really hard to control robots remotely.
Yeah, it sounds like it takes some pretty serious engineering to build robots that can handle all that.
Yeah.
Okay, last but not least, let's talk about robots in customer service. I mean, we've all had those frustrating experiences with chatbots, right?
Oh, yeah.
Well, they just, don't understand what you're asking.
Right, those early chatbots, they were pretty basic.
They were.
But with all the advancements in AI, especially with these models like ChatGPT, chatbot interactions are becoming much more sophisticated.
Okay, so you're saying there's hope for us yet. We might actually get some decent customer service from a robot someday.
I think so. I mean, they're getting much better at understanding human language and responding in a way that feels more natural and more helpful. It can really revolutionize customer service.
I would love that. So it sounds like robots are already making a big impact in all sorts of industries.
They are. And I think, as technology continues to advance, we can expect to see robots playing an even greater role in our lives.
Yeah, it's both exciting and a little bit daunting to think about all the possibilities.
It is exciting, isn't it? But what are some of the things that are holding them back? Like, why don't we have robots doing everything already?
Yeah, good point. What are those roadblocks? I mean, they're out there, but they're not, they haven't taken over the world yet.
Not quite. Well, I think one of the big ones is something called kinematics.
This basically boils down to how well robots can move and interact with their surroundings. We humans, we take our dexterity for granted. Yeah, I can pick up this delicate microphone, or I can grab, a big heavy toolbox, and I can do it without even thinking about it. But for robots, that's incredibly challenging.
Oh, I'm sure it is. We adjust our grip. We use the right amount of force depending on what we're dealing with.
Exactly. And to replicate that level of dexterity in a robot, it takes some really complex algorithms, sophisticated sensors, a real deep understanding of physics and mechanics.
So it's not just about building stronger robots or faster robots, it's about making them more adaptable, precise in their movements.
And that brings us to another challenge, sensing and estimation. So, robots rely heavily on sensors to perceive their surroundings. But even with all the advances in, AI and the Internet of Things, they still can't quite match human perception. So they can see the world around them, yet they don't necessarily understand it exactly the way we do.
They might detect objects, they might detect obstacles, but they may miss those subtle cues, like facial expressions, body language.
We were talking about collaborating with robots in the workplace. If they can't read our facial expressions, it might not be a good collaboration.
Exactly. It can lead to, miscommunication or even dangerous situations.
Right? That's a really good point. It's a good reminder that even the most advanced robots are still machines. They don't They don't have that intuitive understanding of the world that we do as humans. So we talked about dexterity, perception. What about motion control? Even if they can, sense their surroundings accurately, how do they actually control their movements, especially when they're interacting with objects?
Yeah, that's another big one. You were talking earlier about the difference between picking up a toolbox versus picking up a microphone. For a human, that's easy. We just do it. But for a robot, it's a complex equation of force and feedback. Imagine a robot trying to thread a needle or assemble a tiny electronic component. Those tasks require incredible precision and control, which we're still working on.
So we're not going to be replaced by robot surgeons and, skilled craftspeople just yet?
Not quite yet, but we are making progress every day. As AI and machine learning continue to evolve, we can expect robots to become more adept at those kinds of tasks.
Well, that is good news. Okay, so you mentioned earlier that robots can be thrown off by the unexpected. How do you even begin to teach a robot to deal with unpredictable situations?
That is one of the biggest challenges in robotics, because the real world is messy, right? It's chaotic. Things don't always go according to plan, right? You might drop a tool. The weather might change. Suddenly, a child might run out into the street in front of a self-driving car. So we need robots that can basically think on their feet.
So a robot that can learn from its experiences and kind of improvise when it needs to. That's a tall order.
It is. It requires a level of artificial intelligence that we're still striving for. We need robots that can not only follow instructions, but they can reason, they can solve problems, and even anticipate problems.
Wow. So it seems like you need a really deep understanding of so many different fields to build a truly robust robot. You need engineering, computer science, psychology. So it's like this giant puzzle where you have to fit all these different pieces together.
You hit the nail on the head. Robotics is a truly interdisciplinary field, and that's part of what makes it so fascinating.
Right? So, previously we talked about how data is like the fuel for AI. But let's get into the specifics. How is all that data changing robots? Like, what are some of the techniques?
Well, one of the most important ones is computer vision. Giving robots the power to actually see. It's really important for anything that needs a lot of precision. Like those industrial robots that work with those, tiny measurements. Or you've got humanoid robots that need to track human movement and react to it.
So instead of just following pre-programmed instructions, they can actually analyze what's happening and react in real time.
Exactly.
And it's not just seeing. They're getting better at understanding us too. And that's because of natural language processing, or NLP. This tech lets them understand voice commands, which is super important for those collaborative robots, the ones that are designed to work alongside humans.
Right? You wouldn't want to have to type in a super complicated command every time you needed your robot to do something.
Exactly. Voice commands make it so much easier.
More efficient too. All that data processing needs a lot of power. That's where edge computing comes in.
Edge computing? Is that the super brain that's right inside the robot?
Well, yeah. It's basically a way for the robots to process information immediately. Right from their sensors, without having to wait for some distant server. This is essential for, those robots that need to react quickly, like split-second decisions, self-driving cars, navigating, things like that.
Oh, that's incredible. A real-time processing like that could literally save lives in some situations.
Exactly. Yeah.
Okay, but we're also seeing robots that can adapt, and that's all thanks to machine learning, right?
Absolutely. Okay, think of a Roomba. That little robot vacuum? It uses machine learning to make a map of your house, figure out the best route, and even change how it cleans based on different types of floors.
Oh, wow. So it's every time it cleans, it's getting smarter and better at its job. That's pretty cool. But machine learning isn't just about clean floors.
No, not at all. It's also helping robots learn how to grab and manipulate objects.
Really? That seems pretty basic for humans. Just picking things up. What makes it so hard for robots?
Think about it. All those tiny adjustments your hand makes picking up an egg versus something heavy like a textbook. Robots need to learn to, feel objects, Figure out how much pressure to use to avoid breaking things.
Right? I never even thought about it like that. So how are they training robots to, master this picking things up skill?
Well, they're using computer vision, first of all, to figure out the shape and size. And then you've got texture rendering to understand the surface. And of course, machine learning to analyze it all and then adjust their grip. It's pretty complicated.
Wow. It's amazing to see how far robotics has come. So far, we've covered computer vision, natural language processing, edge computing, and then machine learning. Are there other AI techniques that are boosting the robots even more?
Oh yeah, definitely. And it gets even more interesting. We've talked about robots, seeing and adapting. But what about when they need to, actually think things through? Complex situations? That's where these expert systems come in.
Okay, complex reasoning. What kind of situations?
So imagine a robot, and it has to organize this shelf. But the shelf is almost full, so it has to know where everything is and then figure out how to fit in something new, without breaking anything.
Well, that does sound tricky. Like real-life Tetris, but with fragile stuff.
Yeah, exactly. That's where those expert systems are perfect. They're built to think like a human expert, Analyze the situation and figure out the rules and then come up with the best solution.
So it's like a mini expert living inside the robot?
Yeah, pretty much.
Guiding it, helping it make good choices when things get complicated.
Exactly.
Okay, but we've been talking a lot about thinking and acting. What about feeling? Can robots understand emotions?
Oh, that's a good one. It always comes up, and it does seem like something only humans can do. But it's a really fascinating area of research, and the answer is getting, more and more complex. We are seeing AI systems now that can, recognize human emotions.
Really? So they could read our faces and know if we're happy or sad or mad?
Yeah, exactly. And it's not just about, watching. Some researchers are trying to put this technology into humanoid robots so they can interact with us better. Imagine, a companion robot that can tell you're down and, does something to make you feel better.
Oh, wow. That's both amazing and kind of creepy. It makes you think about where the line is between machine and human.
I know, right? It's pretty wild.
Let's talk about intelligent automation.
Oh, okay. Yeah.
So what is it exactly?
It's basically what comes after robotic process automation, or RPA. Yeah, the old RPA was all about doing the same tasks over and over based on rules.
So a robot that just follows the same script?
Pretty much, yeah. But intelligent automation uses AI stuff like machine learning, and that lets robots learn from how humans actually do things, even if everyone does it a bit differently.
So instead of blindly following a script, they can watch how people do it, pick out the best way, and maybe even suggest improvements.
Yeah, exactly. Make things more efficient and adaptable to how humans work.
Right? Because people aren't robots, and we don't always follow the rules exactly. We improvise. But we haven't talked about how they move around. What about motion control and avoiding obstacles?
Oh, right. Well, machine learning is really important there, especially supervised and reinforcement learning. Robots are learning to navigate tricky spaces, predict obstacles, and move around them smoothly.
So no more bumping into walls or tripping over stuff.
Ideally, yeah. The goal is to make them as good at getting around as we are.
Which is tough, given how crazy our world is.
Oh yeah, it's a huge challenge. But we are making progress in so many areas.
It's not just factory robots anymore. It's robots sharing our space, working with us on really complicated things.
Exactly. And as they become more, a part of our lives, understanding emotions becomes even more important. Maybe even expressing them.
Yeah, that is a challenge. But the payoff would be huge.
Absolutely.
Well, that brings us to the end of this deep dive into robotics. We've learned about the 6 categories of robots, their applications, impediments, and how AI is making robots smarter, more capable, and, more part of our lives. But the real question is, what will we do with it?
Right? It's not just about the robots themselves. It's about making a better future for all of us.
Exactly. Next up, we're diving into the latest breakthroughs and challenges in autonomous driving, 3D printing, and how big data and AI are already pushing 3D printing to the next level.
So to our listeners, keep learning, keep questioning, and keep exploring. The future's full of potential, and it's up to all of us to make sure we're heading in the right direction.
That's right. Thanks for joining us, and we'll see you next time.